Hi folks, this is Maths and Physics for you. Today we're going to find the potential function f if we are given a conservative vector field f. For example, f of x, y, z, which is in 3D, equals y squared I plus 2xy plus e3z j plus 3y e3z k. So this is a conservative vector field in 3D. And as you know from previous video introduction to vector fields, a vector field is called conservative if it has a derivative function. This is called derivative function f. This is del f, the del operator. F is the potential function. So we have f, the vector field, equals del f, which could be written as partial derivative of the function f. So df dx I plus df dy j plus df dz k, partial derivatives in the three directions. Now let's solve this problem so that we find f, the potential function. If we compare these two equations, this one, f, and f here, this means that the partial derivative with respect to x, df dx, which we can call it f sub x, must be equals to y squared. So fx equal y squared. And similarly, df dy equals to 2xy plus e3z, which we can call it also fy. And as well, df dz, the partial derivative with respect to z, fz equals to 3y ez, 3z from here, by comparing. Okay, now we want to find f. That's what we are after. Here we have partial derivative with respect to x. So we integrate with respect to x so that we can find f. Okay, this gives us f equals y squared is constant here, because it's integrating with respect to x. So we get y squared x plus a constant, which is another function that has no x, g of yz. So okay, now once we found f in this form, now we want to differentiate it with respect to y. So we get fy and compare it with what we are given, fy here. So if we do the differentiation with respect to y, then x is now constant, so we'll have 2xy plus the partial derivative of j with respect to y, gy yz. This is constant. So this is equation 5. Now we compare this one, 5, which is fy, with fy here, 2. So we notice both of them, they have 2xy. So this means that gy yz must be equals to e3z. So by substitution, we get now fy equals to 2xy, alright, plus gyYZ. Alright, so gyYZ equal to e3z. Now we want g, not gy. So again, we integrate with respect to y, so that gives us y e3z, because that becomes a constant. So y e3z plus another constant now in terms of z, so h of z. Now again, we substitute this equation in equation 4 above here. Okay, then by substituting in equation 4 above, as we just mentioned, we get f of x, y, z now equals to y squared x plus y e3z plus hz. Okay, now we want to make use of the other given information, which is the partial derivative of f with respect to z. We had it before. So we have to differentiate this now with respect to z. F of z, partial differentiation. There is no z here, so that becomes 0. Now here with respect to z, so you got 3, we put it here, so you got 3y e3z plus h dash, the derivative of h with respect to z. Again, by comparing with equation 3 above, okay, in the previous page, we notice that h dash z will be equal to 0. This means that h itself is a constant. So h of z is a constant. Put it back again in equation 7 here. If this is constant, so we put c. We write it back again. So f of x, y, z equals y square x plus y e3z plus c. So this is what we are after. So this is the potential function that we are after. All right, we can also do a step further to satisfy ourselves. We can check that this solution is correct. We can do this by, again, using the equation del f equals f. We want to prove it, that del f, we should give you f, the one that we started with. Okay, so we check df dx, partial derivative. F is what we got here, y square x plus y e3z plus c I. The same thing in the with respect to y. This is f, j, same thing with respect to z, and k. Now if we do the partial derivative for this part with respect to x, that will give you here y square I. This becomes 0, 0, so we got y square I plus, now with respect to y, this one got y, so this becomes 2x y or 2yx plus this one also got y, so this becomes like as if it is a constant, so e3z, this is a constant, its derivative is 0, so this j plus with respect to z, this is the only one that got z, so we got 3 in front, 3y e3z. Okay, and if we look back at the original equation that we were given for the vector field, they are equal. So this means del f equals to f, and it's the conservative vector field, and the f is the potential function required. Thanks for watching. Please subscribe.